Hi everyone, in this video I'm going to be working through some paper 1 type questions. This is a past paper but it's really good revision. Please let me know in the comments if you have any questions. So let's get straight into it. So first of all, we've got some multiple choice questions. So which of the following numbers is rational? Okay, so a rational number, what I would do is you've got a calculator. Put it into your calculator. Rational numbers don't go on forever. They don't have endless decimals and they have to be something that's real. So if you get an error, it can't be a rational number. Okay, so like I said, let's put it into the calculator. So the square root of 3, let's test that out quick. So you're just going to put it into your calculator, check what you get out. So the square root of 3, let's just check that again, is 1.73205. Okay, so it just carries on forever. So as soon as you see something like that where it carries on forever, that is definitely not rational. Square root of 16 we should know. So the square root of 16 is just 4. So that could be our rational number. That could be our answer. The square root of 9, negative 9, you're going to get an error. You can't do a negative square root. So that is definitely not it. And then the square root of 13, let's check that. So square root of 13, again, you get 3.6055127. It just carries on. So again, that can't be it. So that's how you eliminate. So a rational number, it has to be a number that ends. So we call it, it has a terminating decimal. So the decimal ends. Okay, so that is your really quick check for that. They love asking this one, so it's quite a nice one to remember. So that one, if you want a rational number, you just plug it into your calculator, check, do the decimals carry on forever, or do they stop? Either stop really quickly, or they aren't any decimals. If we look then at question 1.2, we've got a ratio question. So there are 120 learners in grade 8 at Greenview High School. If the ratio of girls to boys is 3 to 5, then how many boys are there? Okay, so what we do, if we have a question like this, we have the total number and we want a part of it. What we have to do is we have to say, okay, girls to boys, the ratio is 3 to 5. We want the actual number of girls and boys. So what I would say is we work out the total of this. So we add those together. So 3 plus 5 is 8. And then what I'm going to do is I'm going to say 120 divided by 8. Okay, so let's just do it here. 120 divided by 8 is 15. Okay, and then what this tells us is that's what we got to times both of these numbers by. So we're going to go times both of those parts by 15. So 3 times 15 is 45. 5 times 15 is 75. And then we can see, okay, so I've got 45 girls and 75 boys. So you can always work it out like this. So you work out what's the total of the ratio, you divide it by the total, and then you times it by the answer that you get. So we can see here, the ratio of the girls to boys is 3 to 5. How many boys are there? So there are 75 boys. So what I would always say with these ratios is always try work out, or not with ratios, with multiple choice questions, always try work out the answer before you even look at the options, because a lot of the times these options are just trying to trick you. You can see that 8 there, they're trying to trick you there. 15 is trying to trick you because you've worked out two parts. So you're like, well, that could be a likely number. And then the 55, it's not even an option. Okay, convert the following number to scientific notation. So again, scientific notation, we always want one number and then the decimal. So what we need to do is we need to move this decimal all the way back there. So we have one number. It needs to be a non-zero number. So I'm going to move it all the way back to that 8. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces I'm moving it. And then I would rewrite it then as 8.9123. Okay, just because I just want that one number in front. If it's a really small number like this, okay, we can see it's got lots of zeros, so it's a really small number like that. Then it's a negative at the top there. And we just say how many spaces we moved it. So we moved it 10 spaces, so we put a 10 at the top. Okay, so we can see if we were looking at this, scientific notation is supposed to make it look simpler, so it's definitely not that one. Because it's this really small number, so 0.0000, that shows it's really small, it can't be a positive exponent. So it's one of these two options, and then they're testing you here, so you have to only have one number in front of the decimal. So it can't be this 89 one. Okay, so we can see that is definitely our right answer there for C. 1.4, if the brackets are equal to 0, then x could be. Okay, so if you have two brackets like this, one of these brackets has to be 0. Okay, because if you get an answer of 0, either the first bracket is 0 or the second bracket is 0. We don't know. So if they give it to you in this form, what you say is either x minus 1, so the first bracket is 0, or the second bracket is 0, so x plus 2 is 0. So it's always like this. If you get two brackets like this, they say it's equal to 0, you're going to have two answers in your question. Two answers to your question. So that means either, if we look at this one, if we take the minus 1 across, it becomes positive 1. So either x is 1, or x could be, when we take this positive 2 across, it could be negative 2. And that is going to be our answer. So we have two answers. So x is 1 or x is minus 2. Okay, question 1.5. What is the volume of a cube? Okay, so the volume of a cube is always just length times base, or length times width times height. So length times breadth times height. On a cube, every single side is 7. Okay, so that's what they're testing, to make sure you know that. And so if we do this one, the length is 7, the breadth is 7, and the height is 7. So we're just going to go 7 times 7 times 7. We're going to get 343. And because it's volume, it's a 3D shape, so we get centimeters cubed. 1.6, the transformation, okay, so the movement of A, B, C to D, E, F is called. So what you got to check is it a mirror image? So have you reflected it? So we haven't reflected this one, because if we reflected that, the shape would be the other way. Okay, so it's not a reflection. Let's check what else there is. What are the other options? So it's not a reflection. So reduction. So has it gotten smaller? It has not gotten smaller. It's exactly the same shape still. It has not gotten larger. It's not an enlargement. So it's a translation, which means it's just a movement, which we can see just by looking at it. So translation just means we've just taken the same shape, we've just moved it. So this one, all they've done is they've just moved it across. Let's see, 1, 2, 3, 4, 5, 6, 7 spaces. So they've translated it 7 units to the right. We didn't even need to go that far. All we need to know is it's a translation. Okay, the next number in this sequence. So let's see, we've got 1, 9, 25. What I always try check for is, are they square numbers? Are they cube numbers? Is it easy to add or to times something? So I can't see anything we could add, can't see anything we could times, but these do look like square numbers to me. So this would be 1 squared gives me 1. 3 squared gives me 9. 5 squared gives me 25. So I can see I'm I'm squaring all the odd numbers. So I think the next one is going to be 7 squared, because it's 1, 3, 5, 7. So 7 squared is going to be 49. So it's just really a case of playing around. Sometimes these things are easy to see, but the more of them you do, the better you'll get at picking that out. Okay, which 3D figure has 5 faces, 5 vertices, and 8 edges? Okay, so what I would do first is I'm going to look at the vertices, so 5 corners. Okay, so a cylinder doesn't have any corners, okay, because a cylinder just looks like a toilet roll again. So cylinder has no corners, so that's definitely out. A dodecahedron has 10 faces, and so it's going to have so many corners, so it definitely can't be that one. And then we are down to 2. So let's try draw a really basic one, but let's try draw square base pyramid. Okay, you're going to have to deal with my really bad drawing here. Something like that. And then a triangular base pyramid. Okay, kind of difficult to see that back one. What we're going to do, let me draw that again. We are going to just try see from our really bad drawing here how many faces this one has. So let me draw in a different color. Okay, like I said, really bad drawing, but it's just so we can get an idea. So a square base pyramid, let's count all these corners. So 1, 2, 3, 4, 5 corners. So that could definitely be our one. Let's check the triangular base pyramid. 1, 2, 3, 4 corners. Okay, so really that one's out. So it has to be our square base pyramid. So I would say just choose one of the options and try rule it out like that. For me, corners are usually the easiest ones. 1.9, so why is triangle ABC? This is congruent. So why is it exactly the same? Okay, so for congruency, there's a few reasons. So we could prove it's got side, angle, side. We could prove angle, side, angle. We could prove it's got a right angle, a hypotenuse, and a side. That's the same. We could prove angle, angle, side. Okay, so let's have a look. This one, we can see we're looking at, it's a little bit confusing, but we've got this triangle ABC. So it's this triangle here. Okay, and then the other triangle is this triangle here. We want to try prove that they are exactly the same triangles. So what I'm going to say here is, I'm going to get rid of these scribbles, so it's just so we could see what we're working with there. If we look first of all at, they've both got the same bottom one. Okay, so both of them have the same side there. So we could say that is exactly the same. So we've got one side that's the same. They've both got these sides are the same because they've given that to us. So there's another side. And then what's really nice is if you've got equal sides, you can kind of imagine arrows. So they've got these angles in the bottom here are equal. I don't know if that helps us actually. Let's check some of the options quick. Maybe we can rule some out. So first of all, side, 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 that is how we prove similarity. So it definitely can't be this reason, okay, because that is only for similarity. We can use that. Okay, so it can't be that one. It can't be RHS because we don't know, we don't have any right angles. So it can't be this one. It could be if they gave us a right angle, but we can't use that right now. So we've got to check. Can we use side, angle, side, or can we use angle, angle, side? So what I'm thinking is we don't actually have. Oh yeah, we know. Okay, so we've got a side. We have an angle that's the same because it's opposite and equal side, and then we've got another side. So we can use side, angle, side as our reason there. The hint would be we don't know any of the other angles, so we only know one angle in each. So it has to be side, angle, side because we don't have enough angles to do angle, angle, side. Okay, so we just don't have enough angles to prove that one. Okay, what will be the probability if an odd number is picked from a list of numbers from 1 to 13? So let's write these numbers. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So let's just check how many numbers we have in total, because it's always, okay, so how many odd numbers are there out of how many in total? That's going to be our probability. So we can check how many odds. We've got 1, 2, 3, 4, 5, 6, 7. Okay, so that is going to be how many odd numbers we got. And how many we got in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, which we knew. And so it's going to be probability of 7 over 13. Okay, let's have a look if we can do some other questions here. So I'll try let's see how much we can get done. I'll try keep some space here. So this one, 2.1.1, we have got lots of exponents going on. Okay, we've got fractions like this where it's dividing fractions. What you need to keep in mind is we can do the KFC rule. So keep, flip, change. So we're going to keep the first term. We flip the second term, so we turn it upside down. So at the top, we're going to have p squared q3. At the bottom, we have 10pq. And then we change the sign in between them. Let's simplify that then. So at the top, then, we're going to have 4 p squared times p squared. Remember, if you're timesing decimals, if you're timesing with exponents, you just add the top numbers. So we can actually say p squared, because we've got those, we're just going to add those exponents. So 2 plus 2 is 4. And then q, if there's nothing, you imagine there's a 1 there. So q1 and q3. Again, let's just highlight that. So 1 and 3. So 1 add 3 is also going to be 4. So we're going to have q4. At the bottom, we got 10. So write the number first. So p1 and p1. So 1 plus 1 is 2. So p2. q3 and q1. So 3 plus 1 is 4. So q4. Okay, it's already looking a lot better. So that would be your first mark, is just remembering that keep, flip, change rule. Then what we can say is 4 and 10, we could divide them both by 2. So 4 divided by 2 is 2. 10 divided by 2 is 5. So that simplifies it a little bit. If you have exponents like this, remember your exponent rule. So p4 divided by p2, what we do is we subtract the exponents. So we go 4, take away 2. So we're left with just 2. And then q4, so 4 take away 4, we are left with nothing. Okay, so we don't have any q's there. So that is actually going to be our final answer. So you can write it like that, or you can write it with the number first. So 2 over 5 p squared. Okay, that's really important that you remember those exponent rules. Okay, so if you are multiplying exponents, you actually add them. And if you are dividing exponents, like here, we were dividing q4, we actually went 4, take away 4, so we had no q's in. Let's have a look at this one. So I'll try use a different color so it doesn't get too confusing. Okay, so next up, we're trying to simplify this. So 3x plus 6y, x plus 2y. What I would do first is at the top here, I can take out a common factor of 3. Okay, so I'm going to take 3 out there, put the rest in brackets. So if I take the 3 out of this first term, I'm just left with x. And then 6 divided by 3 is 2. And we can see why we've done that, because then we've actually got the same at the top and the bottom. And so we can actually just cancel those, and all we are left with is 3. Okay, next up, they're testing if we can find the products of things. So let's make this a little bit bigger so we can see what's going on. First of all, we want to find the product of this. They're checking that you know how to multiply into brackets here. So if we're multiplying in, we have to multiply this by every single term in here. And you have to be really careful of the sign in front of it. So if we go that first one, let's see, we can have 3x times 2x. So 3 times 2 is 6. X times x squared. Remember that we imagine there's a little 1 there. We're multiplying, so we're going to add the exponents. So 1 plus 2 is x to the 3. Next up, we got 3x times negative 5x. So 3 times negative 5 is negative 15. And then again, x1 and x1 means we are left with x2. And then 3x times negative 4. So 3 times negative 4 is negative 12. And we keep the x. Okay, that's as far. They just want the product, so they just wanted us to multiply out. With the next bracket, again, they're testing to make sure that you will multiply all the terms that you need to. So with 2 brackets, with double brackets like this, you have to go x times x, x times that one, 3 times x, and 3 times that one. Okay, so let's check. The first term, so x times x gives you x squared. Then we've got x times negative 4 is negative 4x. Okay, so remember that's that one there that we're doing. Then next up we have 3 times x is 3x. And then lastly we have 3 times negative 4 is negative 12. And then this one we can simplify a little bit because we can work with these terms in the middle here. So our final answer then we could say is x squared. We've got minus 4x add 3. So minus 4 add 3 is going to be minus 1x minus 12. Okay, and then 2.2.3, I might need to do this just at the bottom, just so I get some space. Okay, so let me just copy this down to the bottom quick. Okay, so we can do it here or there. So what we've got is we have x minus 5 squared minus a double bracket x plus 5, x minus 5 plus 10x. Okay, we just want to multiply this out. So first of all, I'm going to rewrite this. So if you have a bracket squared, you can rewrite that then. Okay, so a bracket squared, that's the same as saying x minus 5 times x minus 5. Then we've still got that other double bracket, x plus 5, x minus 5, and we've still got that 10x. Okay, let's get some different colors going in here. So we're going to go, remember, first of all, we always go the first term times the first term. So x times x, x squared. Next up, we're going to go x times the last term. So x times minus 5 is minus 5x. Then we're going minus 5 times x, which is minus 5x. Next up, minus 5 times minus 5. So minus times a minus is a positive. 5 times 5 is 25. And do exactly the same for those brackets. So just need to be careful, we got this minus here. So we've got to keep that minus. Let's work out these brackets. So x times x is x squared. Next up, x times minus 5, minus 5x. Next, 5 times x is 5x. And then next we've got 5 times minus 5. So a positive times a minus is a minus. 5 times 5 is 25. And then we've still got that 10x there. Okay, the really important thing, they were testing us here, so we've got to remember to put these brackets because we've got to keep that negative sign. So we're going to first of all see what that negative sign does to these terms. Okay, so everything else is the same. Let's just rewrite all of this. So we've got x squared minus 5x minus 5x plus 25. And then this minus changes the sign of everything in here. So we can have minus x squared, then it changes that sign. So it's going to be positive 5x. Changes this sign, so it's minus 5x. Changes this sign, so it's positive 25. Add 10x. So they were testing to make sure you remembered to use that sign in front there. Now what we can do is we just need to simplify. So I'm going to highlight all the terms that are the same. So we've got an x squared here, a minus x squared there. Okay, that's all of our x squared terms. So let's check those. X squared minus x squared means we actually have no x squared. Okay, so we can actually just get rid of that because that cancels each other. Let's check next. We have got minus 5x, minus 5x. So I'm doing all the x's now. Plus 5x, minus 5x, plus 10x. So let's see. Minus 5, take away another 5. That's minus 10. Add 5 is minus 5. Minus another 5 is minus 10, and then add 10. So we got minus 10 plus 10. So actually we have no x's either. And then lastly, we can just do the numbers. So we got 25, add 25. And so actually this whole thing simplifies to just 50. Okay, so that's going to be a lot of marks for that one. I think I'm going to end this video there, but let me know in the comments if you have any questions, and I will keep working through the rest of the questions in another video. Thank you for watching.